Alright, so I already started working on the valve. It's 3/4 of an inch diameter brass stock. It has to be 1/4 of an inch thick. Uh, I already went ahead, faced it off, drilled a 1/16 of an inch hole, drilled and reamed, and parted it off. And this is about 5 or 6 thousandths thicker than it needs to be. So now I got to make a 1/2 inch counterbore, 1/16 of an inch deep. I'm going to do this on the rotary table because I got other features I got to do afterwards. So so just to hold this parallel and straight, I got a tool bit in here, and we'll get this clamped down, and we'll get the rotary table centered in the mill, and I'll bring you back when I got that done. Okay, so I have a 1/2 inch end mill, the rotary table centered here, and I got to go down a 1/16 of an inch. So let me zero out my readout on my quill here, and we'll go down 62 thousandths. Okay, so I turned the piece over, and this is still centered right now. So now I have a 3/16 inch end mill, and I'm going to move the table over in the X direction, 3/16 of an inch. So let's get started on that. Okay. Right there. Okay, and now this has got to go down 1/16 of an inch as well. And but that's going to get, I'm going to use the rotary table and make a concentric groove, 3/16 of an inch thick. So let's zero this out. Everything locked down here. And let's get started. I'm going to make several passes instead of just going the full depth. Okay, so the next operation we got to do here is I got to drill 1/16 of an inch holes, spaced 90 degrees apart from each other, and those are on a 5/16 of an inch bolt circle. So I went back to the center, and I moved the table for 5/32 of an inch, and have the infamous baby center drill in there, and I'll just locate each of the 4 holes, and I'll come back with the 1/16 of an inch drill bit and complete that. So Alright, you see me back up a couple of times, that's because I overshot it, and I just wanted to make sure that I took all the backlash out. So, alright, got a couple more things to do on this, and this piece will be done. Got to cut a little oil groove around the middle of this here rim, and I got to flip it over, do the same on the other side. So, I'll bring you back when we're ready to go. Okay, here we go. I got that homemade engraving toolish kind of thing, whatever you want to call it, in there, and I'm going to go down about about 4 or 5 thousandths, and go around the circumference. Alright, that looks pretty good. So I'll flip it over and do the back side, and bring you back in a bit. Alright, after I got the engine assembled, I was having trouble. I couldn't get the engine to run. And I, I narrowed it down that the problem was somewhere with the valve. And so, I went back and forth trying different things. And what I've come to the conclusion, what had happened was that the valve needs to be a real precision fit between the bottom of the housing and the back of the crankcase, because this is going to be rotating in that kind of a fashion. So let me show you. Okay, so here's the back of the engine. Let me get you in frame here. Okay, so what's happening is, hope you guys can see this here. So as the engine rotates, you can see the valve pin. These are your air inlet passages which go up to the cylinder, and then allow the air pressure pushes down each piston. So as the engine rotates, all right, the valve housing is over this, air pressure or steam is going in, and it's charging this area here. And so as you can see, as the engine rotates, this valve, the valve is allowing the exhaust to flow out into the cavity and then out through the exhaust port, and it's charging, it's starting to charge these cylinders. As it rotates around, it's starting to let air into that one. This is in, I guess it's power stroke, and then as it comes around, it's starting to charge this one. This is in its exhaust stroke. This is in its exhaust. So that's how this valving works. The problem is that I was getting leakage between this area here and this open area in the valve cavity and in the valve housing, and it was also charging the cylinder here, which this was supposed to be on the exhaust stroke. So what I came up with was, rather than making a new valve, you guys can see, I machined the groove in here, and I put an O-ring in. This is a Harbor Freight metric O-ring from their kit, and after I did that, I did have to thin this down a little bit because it was too thick, it was binding. But once I did that, the engine started right up. So that's a little modification I did in order to get the engine running.